Thank you. What's up? Kia ora, tatou. It's great to be here, and like Anna, it's my first time, and so I'm really enjoying it. First time to New Zealand as well, so yes. I'd like to pay my respects to the local iwi, and many thanks to the NDF organisers for inviting me to speak about our most successful Born digital collection project, FrogID, developed with people power. I'll grab my slides. I really love my job at the Australian Museum, as not only am I leading digital content production and product development, I get to work with some really inspiring people like Dr. Jodie Rowley, who are helping them, to help them with their critical natural science research, and as well as curators on our shared mission to be leading voices around the value and richness of life, the earth and culture in our region. Sorry, I'm a bit nervous. Jodie told me that frogs are the most threatened species on the planet. Now that's a problem statement. How can digital technology help to save frogs? Together with our CEO, Kim McKay, we conceived of the FrogID project to help Jodie with her research by collecting better data around frog distributions in Australia. And because frogs are key indicators of health of our habitats, we really wanted to get the real data into how the environment is changing with the climate crisis. Over the past 6 years, it's become a passion project for all of us involved and has established the go-to data set for frog distribution with real conservation outcomes. Now, you may not know this, but every Australian species of frog has a unique call. And it's an amazing insight because a lot of frog species look very similar. They're also nocturnal, so you don't usually see them, and they, have amazing camouflage. They're tiny, but you often hear them in the environment. So experts and some amateur herpetologists can actually learn to identify species by hearing their call, by their vocalisations, and by their territorial or mating calls. Something I just want to add as a disclaimer is that this project wouldn't work particularly well in New Zealand because your native species of frogs don't actually call. But it would have a very valid application in that you would be able to track the invasive species, our frogs, that have ended up over here. So I think it would work just as well. I actually went frogging last night and I realised how important it is that they do call because we couldn't find any, so it was a bit disappointing. So FrogID was conceived as a non-invasive mobile tool for people to record between 20 to 60 seconds when they hear frogs calling. It's since become our most prominent Born digital collection project. It has got legs. It just continues to grow, and I'm always amazed how well loved this project is. It's incredibly popular. We've won lots of awards around our community engagement in particular, as well as the source of data for conservation policies and dozens of scientific papers. And it's even resulted in the identification of new species. Now, this is a high-level roadmap. I'll show some sort of technical slides, but not really, just to illustrate the digital product development since 2017. So there's been many improvements along the way, but overall FrogID is a success story of what a pretty lean startup approach can look like to developing a mobile app that people can use to identify what is that noise. We had an idea. We undertook audience research to validate user stories and developed a value proposition for their engagement. We invested in a detailed comparative analysis of similar animal identification tools and citizen science mobile apps. Then we prototyped what a nighttime user experience would look like as high-fidelity UX designs, even before we started thinking about any kind of solutions. And then we used these designs, we gained support from IBM to help us build the apps. So following launch of the MVP with that partnership, We've had plenty of bug fixes along the way because it was pretty innovative in its approach. And we also made a lot of improvements to its functionality, so we kept kind of developing it. And once a critical mass of data was collected, we produced data visualisations of the project, which was particularly helpful for local governments to understand what species are in their area. And we continue to grow engagement with better dashboards for our users, including building out badges for them to collect. And as our ambition was always to produce a frog Shazam of sorts, we've started to experiment with AI. Over the past 5 years, we've grown a national community of over 50,000 active users submitting recordings of frogs. It's crazy. I just want to stress the value of our early activities and what you've been hearing in some of the presentations, particularly using the comparative analysis and understanding our target user needs. Having this research before any technical solutions were built allowed us to identify the features of a free mobile app that would harness digital technologies and public participation for rapid, large-scale biodiversity data collection. Investing in a review of similar apps gave us a better understanding of citizen science technology and similar interactive frog field guides. So we knew from the outset what worked really well and what didn't before we built anything. We also identified our target audience personas to understand their needs and their use of technology. That was really important to us as the community that we were about to build. With the citizen science project. So we could ensure our users were engaged with the project to keep making submissions. We defined the value of the project was not only as an audio capture tool for our research purposes, but needed to be a frog field guide as a resource for our users, and also to have a frog call matching function that would help teach citizen scientists, those really engaged amateur herpetologists, what species they could hear calling for themselves. This is the original project team. So we commissioned high-fidelity wireframes by a really talented group. So I invested a small amount of seed funding in this project from my own tiny budget of what a sort of frog call matching app would be, which was our original kind of concept. And it demonstrated the proposed features and functions, and we're able to value that really secure partnership by having that documentation from the outset. And then you can see in the background lots of post notes. We did lots of iteration over a period of months before the IBM team developed the MVP of the iOS and Android apps in 2018. This is kind of the original designs, and you can see there are key home screens and sub-screens that were mapped and iteratively tested to create the most simple pathways to the main FrogID app functions, with the key goal to record frogs when you hear them calling. There's ways to filter frog species in the field guide, and that was what, we sort of got a lot of good insights from comparative analysis. And the What's Near Me feature is the primary form of filtering from the outset. So wherever you are, you can open the app and find out what frogs are in your area. Over time, we further refined the app based on user feedback with yearly upgrades, including changing the landing screen so that when it opens now, it goes straight to the record screen instead of the field guide, because we want to make sure it's really easy for people to record frogs when they hear it. So the mobile apps were launched in 2018 with a significant PR campaign to raise awareness of the new apps on both devices. And the Australian Museum also partnered with natural science museums across Australia to share the project and the call to action to engage in citizen science to count frogs. By gathering a 20-second recording of frog calls, along with the GPS location and timestamps, the mobile app collects data about frog species distribution for researchers to gain a deeper understanding of the health of Australian habitats. The data submitted are virtual vouchers. It's proof that the species existed in a time and place. These digital records are pretty much just as valuable as the physical vouchers held in our museum collections. The app would be nothing without the communications team engaging the community and driving awareness. Jodie in particular is a great science communicator, and we also have a project coordinator, one person on the team managing and engaging the community through events such as our yearly FrogID week. We regularly survey our audience about feature improvements and have identified key audiences as retirees, nature enthusiasts, farmers and environmental groups are really key, with scientists and councils the key stakeholders in the data collected. Key to the project's success is this, as a citizen science project, is this community engagement. And so since launch, we put effort into developing our user profiles with personalised maps of your captures, badges to collect, and leaderboards to encourage participation. People are amazing in how much they want to start to collect the badges as well. It's nice. People love the personalised messages in the emails that they receive when submissions are validated. Not everyone knows at first that these recordings are actually listened to by our experts. But it's become a really important motivating factor that there's somebody out there actually listening to your submission. So I'm very mindful of this in understanding our success of re-engagement with citizen science projects, that human factor. The project has been wildly successful, with people from across Australia contributing a recording of frogs when they hear them to map frog distributions across this country, or our country, sorry. This is the largest scientifically backed, acoustic-based citizen science project in Australia's history, with the data helping us to better understand and conserve Australia's frogs. The success of the project is in the numbers. 46,000 users actively submitting recordings. Over 780,000 calls in the dataset. We're about to reach 1.3 million verified frogs, and recording 231 species out of 240 is an incredible outcome that no team of individual herpetologists could achieve in their lifetime, let alone within 6 years. FrogID has even helped discover new species, as I mentioned. But this success has also caused a major pain point. The large number of submissions to the project has created a backlog of audio requiring identification. The current FrogID application relies on manual validation of frog calls. Experts literally listen to every submission and identify the various frog species in the recording, or if it's not a frog, which is often the case. We get some very interesting sounds of Australia. With a backlog of up to 30,000 recordings awaiting classification, unfortunately, even users of free mobile apps can get frustrated with the wait time for feedback. This is the problem we are now trying to solve with AI. By using machine learning, we are training models using our FrogID dataset to identify frog species, with the goal to provide near immediate feedback to users who submit a FrogID recording. With the impressive dataset of over 1 million frog calls across the 230 species and over 150 submissions a day, we are working to understand how AI is best embedded into the FrogID application and infrastructure, as well as implementing an MLOps pipeline for training models using our amazing dataset of bioacoustic recordings. Any digital product development, we need to consider future resourcing and be sustainable. We're not wanting to contribute to the problem. We are committed to advancing our FrogID project's success using AI solutions to triage submissions and enable real-time biodiversity monitoring, but we also need to understand the costs involved. Advancements in open source pre-trained models over the past few years, coupled with more affordable MLOps capabilities in platforms like Google, Colab and Databricks, have made it easier for us to experiment and innovate with AI processes and solutions. We've commenced experimenting with AI by using pre-trained models with the tagged FrogID audio datasets, as there are already bioacoustic models that have demonstrated capabilities in audio classification using deep neural network models. These models have been used for prediction of species across a variety of domains, most commonly for birds. To summarise the approach, we will leverage a pre-trained bioacoustic model that has learned how to encode audio data based on bird vocalisations. This pre-trained model will be used as is to convert our FrogID data into smarter representations known as embedding vectors, and then these embedding vectors will then be used to train a neural network classifier which outputs a species prediction. So easy. And that's just the beginning. With the support of a federal government innovation in biodiversity monitoring grant, we've entered a focused stage of ML model development to identify 15 common species of frogs and the invasive cane toad. Working with an agency to implement the MLOps lifecycle for running the FrogID AI feature in our project, we need to ensure we can continue to develop models in a sustainable way. Our team is also ambitious to train the first frog vocalisation embedding model. As most pre-trained, sorry, can you just scroll up? Thanks. Up. Thank you. Sorry, I'm reading this bit. Okay, so the goal is to incorporate the ML process in the application to return frog species results with a prediction accuracy rating to our users for near immediate feedback. Our team are also ambitious to train the first frog vocalisation embedding model, as most of these pre-trained models available have been developed specifically for bird vocalisations only. So with the assistance of a donor, we've also engaged a machine learning engineer who's focused on that particular project. And so you can see the cycle here. This is just training the models and deploying them and running them potentially in the application. Early experiments in 2022 with Atlassian showed promise. You can see here the process of transforming audio to a visual spectrogram and extracting the frog call data. But many of our submissions are from very complex audio environments. You can see here the real challenge will be classifications of the multiple species of frogs calling. We often have like 15 species of frogs calling in a chorus, so it just becomes a wall of sound. So it's hard enough to hear it, but they can still identify what it is. But visually, it's going to be very difficult to kind of extract the frog calls or the image recognition from that. And also when species calls overlap. So you can see here there's one species, but they're all overlapping. So frogs rarely call on their own, so it's a very challenging project. We also need to redevelop our whole FrogID application CMS and modernise the infrastructure from the earlier 2017-28 to support this future incorporation of the MLOps lifecycle for FrogID ML models to be, machine learning models to be embedded in the product, as well as re-architecting FrogID data management to support and govern the AI process. So this slide shows a proposed redesign of the FrogID apps to include the AI results and, making it really obvious that this is the AI result, it's not our experts as well, and the additional MLOps activities, which include audio collection and data preparation, metadata and feature extraction, the model training, the evaluation, the model prediction output for application integration, and then the continual improvement and monitoring. And then we want to have the ability to turn it all off, as we are still uncertain of the overall costs and the benefits to the project, especially if the accuracy of predictions are not high enough for our project's important scientific reputation. And given that the diversity of audio environments submitted to the project, we might find that we're just not getting enough bang for buck. So what is the impact and what are we learning from listening to frog calls? How is a 20-second recording of their call helping scientists understand and protect frogs? In short, a lot. We've collected scientific data on declining species, new species, how frogs are responding to drought, fire and urbanisation, and what environmental cues frogs use to breed. These seemingly short recordings become valuable windows into the complex world of frogs, the sounds of Australia contributing significantly to their protection and our understanding of their ecological needs. The FrogID team has authored or co-authored more than 30 scientific publications using FrogID data. There are also many external researchers citing FrogID data and using it for their biodiversity conservation and ecological research. Before FrogID, traditional frog maps lacked accuracy, like the Global Amphibian Assessment maps from 2 decades ago. Thanks to the Australians recording frog calls, we now possess the vital data for refining these maps. Accessible via the FrogID app, these maps also aid land managers, researchers and biodiversity enthusiasts to understand which species inhabit their region using that near me filter in the field guide. Knowing where species occur is crucial for their conservation. The FrogID's project impact also extends to aiding biosecurity agencies to verify cane toads, an invasive species of great concern in Australia, and he also looks like someone else, by regularly providing FrogID captures of cane toads as records to government and environmental agencies. We contribute crucial data documenting the spread and establishment of cane toads across our nation and are providing an early surveillance alert for their incursion into other states. This collaborative effort showcases the power of citizen science to protect our native ecosystems. Finally, FrogID users are primarily motivated by the program's aim to collect scientifically valuable data on frogs for conservation purposes. This project really is all about the impact people can have in using technology to help save our natural world. It's connecting families with country. And I love to see these kind of comments about intergenerational bonding over frogs, going frogging. It's amazing. By understanding frog populations through collecting better biodiversity data and having accurate information about the health of our ecosystems, FrogID demonstrates how citizen science and data science can have real natural science outcomes. I'd like to acknowledge and say thanks to all the people who have been involved in FrogID over the years and to the organisations who have partnered with us to help develop this project. It's been such an impressive team effort. And please download the app and get involved when you visit Australia. Thanks for listening.
Thank you, Megan. So we do have a lot of questions. I would suggest that you have a look at all of them because we're not going to have a chance to get through them. But there's one in particular, and that is, can you tell us a little bit more about your decision to create an app from scratch rather than using something like iNaturalist?
Yep, that's a great question. We use iNaturalist. We have an Australasian Fishes project happening at the same time. I always leverage things as much as possible. I think we actually predated iNaturalist, so I'll have to look at when that happened again. I do remember seeing 2018, they were coming out and talking about it in the California region. So our projects kicked off at the same time, if that helps explain that reasoning. But also now this data is part of the Australian Museum's Born Digital collection. So we manage it, we maintain it, we preserve it, and that's that point of the virtual vouchers.
And actually, there was a couple that were kind of similar in that. What do you do when you're in areas where you might not have mobile reception?
Yep. So that was built in from the start. It basically, as soon as you're back in Wi-Fi, it can resubmit at that point, so it saves the calls. It's kind of painful though. You do need to kind of set up your account before you do it. So that was part of those learnings and user feedback to make sure that when people download the app, they know to sort of set up the account, so at least they're kind of recording their frog calls at that point. But you do become experts after a while. A lot of the bug fixes are about GPS locations, and it's, you know, sometimes it gives you the wrong data. It's been a very interesting learning about the complexities of having that kind of unique Australian problem of having terrible coverage on the whole. I keep trying to get Telstra to partner with us, but I think they're terrified because it'll just pull out all the gaps in the coverage around our country.
Fabulous. Thank you so much. So that's all we have time for of this session. So if we could give one more clap